right, we're still on Unit 2, Day 1, and we're working on page 3 here, where I'm going to introduce this idea of instantaneous rate of change. So, in the previous pages, we were talking about average rate of change, the slope of a secant line. Now, my question is, on this graph here, which is a graph of f of x equals x squared, I want to know what is the rate of change right at this point? X equals 3, the instantaneous rate of change at that exact point. Now, that may make you think, well, that's not logical. How do you have change if you're sitting at a point? You're not going to the right, you're not going to the left, you're sitting at one point on the graph. How could I ask about change occurring at that moment? But intuitively, we do get a sense of at this point, if you're standing right here, it's increasing at least. And more so, if I were standing up here, where I would get a sense of it's increasing but steeper, right? So you do have an intuitive sense of it. This is increasing down here towards the origin. It's increasing, but it's shallower, so it's increasing slower. Now, to interpret exactly what we mean by instantaneous rate of change, I'm going to use average rate of change. I'm going to pick a point just a little tiny bit above x equals 3. I'm going to select x equals 3.1. Now 3.1 is just a tiny bit above on this graph. Just for sake of ease in drawing this, I'm going to put it up a little bit higher than it would be. It's not to scale, but it makes it easier to draw. So here's x equals 3.1. If I went to the point on the graph when x equals 3.1, we could label that x is 3.1, the y value happens to be 9.61 at that point. And now if I would then find the average rate of change of the function at that time. From 3 to 3.1, the slope of the secant line. From 3 to 3.1, what is the average rate of change? Now, if you do that calculation, y2 minus y1 over x2 minus x1, you will get a slope 6.1. Now, my goal again is to find the slope at the instant when x is 3. So the next thing I'm going to do is I'm going to just get a little closer to x equals 3. Instead of 3.1, how about we look at 3.01? That's even closer. So again, it's not to scale, but we'll say it's right here. 3.01, closer to x equals 3. Now if you label that point on the graph, it would be 3.01. And the y value at that time is 9.0601. And again, I'm going to find the average rate of change. So it would look something like this. And if I calculated the slope of that secant line, the average rate of change from 3 to 3.01, you would find that the slope is 6.01. I did y2 minus y1 over x2 minus x1, and you'd get 6.01. And again, my goal is to find the slope at the instant when x is 3. I'm going to do that by getting even closer. Let's look at x is 3.001. So that's even closer to x equals 3. If you were to label this point, this is x is 3.001, y is 9.006001. I'm really close now to x equals 3. And now I'm going to draw that secant line again, and this will have a slope when you calculate change in y over change in x. It'll be 6.001, and I'm starting to see a pattern here, right? We can definitely see as I get closer and closer and closer to x equals 3, these slopes seem to be getting closer and closer to 6. Right, so over here on the left-hand side of the page, I'm just jotting down where I got those. It looks like when I did slope from 3 to 3.1, 6.1. And then it was 6.01 when I got closer. Then 6.001 when I got closer. If I continue doing that, I think it would be 6.0001, 6.00001, and so forth. It's approaching 6. We could do the same thing from the left side of x equals 3. I could sneak up on x equals 3 from the left side. So for example, I could go from 2.9 up to x equals 3. I could go even closer, 2.99 up to x equals 3. I could go from 2.999 up to x equals 3. And as I get closer and closer and closer, I jotted down those slopes for us already. I already got those calculated for us. If you found those slopes, you would find that they are 5.9, and as you got closer, 5.99, and as you got closer, 5.999. Again, I see the slopes are getting closer and closer to 6. So, as the secant lines get closer and closer to being right on top of x equals 3, the slopes of those secant lines get closer and closer to being 6. And go right back to the original. The question was, what is the instantaneous rate of change right at x equals 3? I was approaching it with secant lines that are getting closer and closer to x equals 3 and finding that the slope of those secant lines was getting closer and closer to 6. What I conclude from this is that if I were able to draw a line that just touched only x equals 3, it wasn't a secant line at all, but it was a line that seemed parallel to the graph, right at x equals 3. The only point it intersected is x equals 3. If I could draw that line would be called a tangent line. And what we're showing here with our approaching secant lines is that the slope of this tangent line is 6. The secant lines themselves got closer and closer and closer to being this tangent line. The slopes of those secant lines got closer and closer and closer to being the slope of this tangent line. This number 6 is the instantaneous rate of change at x equals 3. It's not an average rate of change. It's right at the instant when x equals 3. The rate of the function is 6. So instantaneous rate of change, we could think of this in a few different ways that are um, phrased a little differently, but really they're all equivalent. Instantaneous rate of change is the slope of the tangent line at that point. Instantaneous rate of change is the limit of the slopes of the secant lines at that point. Instantaneous rate of change is the limit of the average rates of change at that point. Let's try this example down here. We have a different function. F of x is x squared plus 6x plus 3. I've already created a sketch of that here for us. And we're going to hone in on x equals 1 and identify the instantaneous rate of change when x is 1. So there it is labeled on the graph, the point 1 comma 8. It first asked us to find the average rate of change from x is 1 to x is 1.5. I'm going to have Excel help us with the quick calculation here. So in Excel, I made a little input-output table. I'm going to plug in x is 1 and x is 1.5. I have the function values over here on the right. So for example, 1, 8 is a point, and the other one here is 1.5 comma 9.75. And then I added a column to the right that calculates the average rate of change between those 2 points, y2 minus y1 over x2 minus x1 in parentheses. So when I pop that in Excel, I see that I get 3.5. So on average, if you travel from x is 1 to x is 1.5, the function goes over 1 up 3.5 on average. I'm interested in finding the instantaneous rate of change when x is 1. So I'm going to get a little closer. I picked two values here in part B that are very, very close to x equals 1. I picked 1.00001. It's very close to it on the right. So if we were to draw that, it would be 1 and then just a tiny bit to the right, 1.00001. If you drew the secant line between those two, it is almost indistinguishable from the tangent line. It is so close to being tangent line. When I find the slope of this secant line, it should be really close to the slope of the tangent line. We're also going to do it for x is 0.99999. Again, when you draw that, here's x is 1. 0.99999 is right here, just a tiny bit to the left. And if you draw that secant line between them, it is almost indistinguishable from the tangent line. The slope of this secant line will be very, very close to the slope of the tangent line. Again, I'll go to Excel. I want to find the slope from x is 1 to x is 1.00001. It tells me that the slope, the average rate of change, is 3.99999. Now I'm going to do it from x is 1 to x is 0.99999. So I put that x value in Excel and I get 4.00001. So both of these values are extremely close to 4. As I got very, very close with my secant lines, the slope of those secant lines gets very, very close to the slope of the tangent line. I think I can conclude from this that the instantaneous rate of change of f of x at x is 1 is 4. To interpret that number 4 on the graph, we're saying at this point 1 comma 8, when x is 1, if you drew a tangent line, a line that only touches the graph of f of x at that one point only, not twice, just there. It's like parallel to the graph right at that time. If you drew the graph and its tangent line, the slope of the tangent line is 4. The instantaneous rate of change of the function at x is 1 is 4. The slope of the tangent line is 4. The limit of the slope of the secant lines is 4.